Hi, in this video segment, we're going to sort of look at more closely each type of the 9 charts that we saw earlier on in the gallery. Because in the gallery, it's more to just give you a sort of summary page of what is possible. We didn't actually show you the command lines to run it. So how do we actually get each chart? Now, I'm starting off with the data frame that we defined in the first slide. So using that, all right, calling it DF conveniently, we'll just run plot.figure. Hope by now you see why we have to do this is to start off a new figure, right? So we don't want any DF plot earlier on to be piled on top or piled on top by our latest DF plot commands. So we start a new figure, instruct the library, please start a new figure. Remember what's a figure? Figure is the all over encompassing drawing area that may contain several x's, but we are at liberty to only draw one x, so that's fine. If we don't specify the single axis, did I say draw one x? That's because I see the variable x. Draw one axis. So if not specified, that only axis will sort of be scaled to occupy the entire figure. So we will just do a df plot.line without saying anything, and out comes an axis, right, being assigned to variable x. So this axis will actually use the dot index as the x-axis, and the rest of the columns, because I had 4 columns, they will be used as y values. So all the xy coordinates are clearly defined. Then we set the axis title to trend lines, and then that's how we get this. For area, simply change it to dot area, and then that's it, right? So very simple. Um, Next up, we have create a new figure and then plot df as bar. So if you do a dot bar, or as we discussed earlier on, another form of dot plot is to say df dot plot kind equals to bar. The spelling is the same. The difference is that the dot bar is programmatically fixed. When you program it this way, when you run it, it can never be changed by user, obviously, hopefully not. But if you use this syntax, you can allow the user to choose. Now, user may say some scary things like kind equals to XYZ. Obviously, you don't let user have free play on any spelling. You will check, right? Is it pi? Is it line? Is it bar or bar h, right? If so, then kind equals to input nature. So you can always do some if else checking first. But at least this form, kind equals to nature, allows us to, during program time, realize what kind of chart we need and then plot accordingly. So this is a vertical bar chart, horizontal bar chart. Now, sometimes we are constrained by the vertical space, but we are allowed to expand horizontally. So not surprisingly, on my horizontally longer screen here and the slide here, this vertical bar chart seems to look better, right? But for the horizontal bar chart, being scaled to the same size for the axis, we find that the bars are so skinny that it's very hard to read, right? The colors normally are well chosen. You notice I didn't choose a color, but the colors are kind of automatically chosen by dfplot if you don't choose any color. So it is not going to choose nearby colors like blue, light blue, navy blue, silver blue, so it will make it very, very hard to read, right? And the point is make it easy to detect or sort of visually impact the eyes to get data sensors. So PyPlot will automatically choose the right color scheme, and usually it's quite also visually pleasing. Next up, we have histogram, kernel density plot, and box plot. So the box plot is not box plot, but just dot box. So dot his, dot kd, dot box, and that's simple as that. So you notice it's all based on the same data frame, and that means we can actually present different aspects of the data frame using dot plot. In this case here, they are all actually some sort of distribution. So statistical distribution display. Histogram is the frequency of occurrence. Kernel density is similar actually, but made continuous using approximations like that. And then finally, we have box plot where each column shows its own distribution, statistical distribution. And they are kind of related, and you can consider maybe instead of using histogram, I can use KDE, or else I should be thinking about box plot. So depending on the intended communication message and circumstances. So over here, um, these are the bar charts. Again, they are also bar-like, but they are totally different from the meaning of histogram. Histogram shows frequency and it's sort of a void of time. So if you want to show time series, as time passes, the red bars shrink and then grows again. Not using histogram. Bar charts maybe, but better still, trend lines, all right, or area. Okay, then we have these two, which are basically allowing the two x and y, two different variables, two different series, to move independently, right? But when they move independently, yet they show certain patterns, like a curve, like a line. It's up to us to see the pattern. Our eyes can detect the pattern much more readily than computer and robots. Well, it's debatable. As technology progresses, we might see at some point overtaking us already in certain areas. But by and large, if we have to look at certain aspects, all right, maybe it's crime scene, maybe it's some sort of a dark, no, dark, not dark, but far and therefore darker perspective version of a car, of a vehicle. That means it's slanted looking, where closer to us looks longer vertically and further away looks shorter. That kind of perspective identification of an image or a pattern may not be so readily doable for even with technology. So there are still challenges and difficult places, right? So this is where visualization helps a lot, right? And scatter, same thing. It may be just based on two variables, so nothing complicated, yes and no. Because by the time you train a neural network AI to detect any pattern, you might as well just look at it and say something weird is going on there, right? So it's about the sort of setup time, efficiency thing. So scatter plot, almost all the while we just have a look at it first. Very, very useful. Hexbin is a sort of related version of scatterplot, showing more by sort of summarizing the occurrences of a lot of dots as a bin, something like that, with a color scale as well. So definitely use the right plot. Now I want to talk a little bit about bubble plots, which of course, number one, it's supported in Excel, so pandas better supported, and yes, it does. Number two is really powerful because it's actually supporting 4-dimensional display. Now you might be wondering, is it possible? Because we all know X and Y is 2D, right? Here in this case, when we show 2D, scatter plot that's 2D, all right, the additional dimension 3D is coming from the size of the bubble. So for example, the bigger the bubble, the more intense, the higher the occurrences, the more severe is the case, right? We can show that by data. And how do we do it? It's looked upon as a scatter plot. So we'll call upon a scatter plot and say that use the x-axis, use the C column as x-axis, D column as y-axis. Is always x comma y, x comma y. So unlike data frame dot log dot ilog, where it's row comma column, that's row kind of like a y comma column, but it's not confusing because we keep saying row comma column. For plotting and anything to do with charts, whether it's pandas plotting, seaborn or payload, it's always x comma y. It's the standard convention, so don't try to change it, right? So x comma y, and the size, S for size for scatter command, size is dependent on the data frame B times 50. So that, it can be more visually impactful. If you don't times 50, big blobs 2 pixels wide, small blobs are 1 pixel wide, you can hardly see the difference. It's not so impactful. So we times 50 to scale it. Doesn't mean the data did multiply by 50 times. And then we color it red uniformly. All bubbles occur red. So this is three-dimensional plotting. C versus D versus B. Three-dimensional plotting. But you can see that we actually can change color if pandas supports, and pandas supports. So if we are able to change color based on the nature of the data, all right, maybe it's some sort of a rainbow scheme, color gradient scheme to deal with continuous colors, then the stronger the color, the more severe is the case. Also possible. Or if we deal with discrete colors, then we say, oh, blue is one category. All right, all blues belong to sort of one country. All reds belong to another country. So by category, all blues belong to precinct 1. All reds belong to precinct 2. All greens belong to precinct 3. Then, because visually the color is so attractive, it instantly teaches our eyes to see patterns based on colors. So that's very, very powerful, using color as another dimension in addition to um, the size, the radius, right? The size of the bubbles, the position X and position Y of the bubble. So actually 4-dimensional display using color bubble plots. Very, very powerful and useful, and it's so easy to set up. For color, we just set up a color map like this. So remember our data frame A has been set to only 2 or rather 3 different numbers, 1, 2, and 3. Now if you have other additional unique numbers, you should define them here, otherwise pandas doesn't know what color to plot. So we have allocated red for ones, 2 for line, so all the 2s in column A are colored red, and 3 for royal blue, like this. So once you do that, you can just do the same, scatter C comma D, size is DMB dot times 50, and then color C is based on column A and map to, or map with, remember map? Column A, df.a is a series. So for the series, we see, for example, 1, 1, 1, 2, 2, 2, 3. So what we need to do is to convert the 1, 1, 1, 2, 2, 2, 3, all right, into red, 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 lime, 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 royal blue. So this is basically a programmable content transformation. So what we do is that use a color map function. We can create a lambda, or we can supply a dictionary like this. Both are the same. Both are the same. All right. So fortunately, map is able to take a dictionary and treat the keys as items in the series to be transformed, and the values will be the transformed to values. So all the ones become red, all the twos become line, all the threes become royal blue. And this returns an AX. We are done here, except we just say dot set title, and this is done. So 4-dimensional charting. This is the most powerful I think we can think of for now.